All right, so let's take a look at example number 15 again. Now, we had mentioned before we left this that we could use things that we know if we had this as one log and not two, okay? And so we're going to do exactly that. Let's condense the left side of this equation. Log base 8 of x times x minus 12 equals 2. Okay. So that's how we use that product property to condense our log. This gives us access to a whole nother level of log equation, okay? Where do we go from here? Now that we have our single log, what is a reasonable next step? Turn it into the exponential form. Good. Okay, so when I write this in exponential form, I'm going to get x times x minus 12 equals 8 squared, right? 8 is our b, 2 is the number that I'm raising it to. 2 is my exponent. We want to be careful about our arithmetic here. We're going to distribute x squared minus 12x. But once in a while, we're just working a little too fast and we're like, oh, x squared or 8 squared is 16. And I know that we know it's not 16. I know we know it's 64, right? But that's really a good place to just stop, check yourself, make sure you didn't make any silly arithmetic mistakes, okay? And now here we have it again. We have our friend the quadratic, so we're gonna move everything to one side, set it equal to 0, and factor so we can solve this equation. All right, I need a pair of numbers that multiply to make 64, but add or subtract to make 12. Ooh, on it. Negative 16 and 4. Beautiful. So x minus 16, x plus 4 equals 0, which means that x minus 16 equals 0 and x plus 4 equals 0. And x equals 16, x equals negative 4, all right? But remember, before we are like, yes, I factored and I'm so proud of myself, which you should be very proud of yourself for factoring. But before we get too excited and we box off our answers, we need to plug them both back in to the original. If we end up with a log of a negative number, then that answer is a no-go and we need to cross it out, okay? So tell me about 16. I plug in 16, do I get log of anything negative? I shouldn't, right? I should get log of 16 or log of 4. Those are both absolutely fine. So I can say with confidence that x equals 16 is a solution, okay? But what happens when I plug in that negative 4? I can almost see it right off the bat. I plug in a negative 4 there, I'm going to get log of a negative number. So if that happens, I want you to cross that out and write domain error. Same message you would get from your calculator, okay? That x equals negative 4 is not a solution, but x equals 16 is, okay? Now, sometimes when you're doing these on WebAssign, they just want one answer. Like they want the answer it is. So if you type in both, they'll tell you it's wrong. But instead of like guessing which one it's gonna be, like I want you to just plug it back into the original and walk yourself through this process about why it is the number that is the solution, okay? All right. Any questions so far about number 15 or any of the stuff that we've covered? Uh, yes, let me modify that statement a little bit, okay? So if you have log and the number, like you simplify the inside and you end up with a negative number, okay? After you've simplified, then yes, it will be a domain error, okay? All right. Any other questions right now? You're welcome. Okay. All right, well, let's go ahead and try number 16. Okay. So, number 16. What are our thoughts here? This is the end of it, yeah. Whatever we finish today will be the end of the material for the exam. I think one thing we can kind of start to see though is like all the topics are pretty connected. So it's important to make sure we know the connections between the topics, not just like each individual topic. Okay. All right. What are some strategies that you have for number 16? What might be some things to try if you were just looking at this and you're like, there's no directions. How do I solve this? What would you want to try first? All right. Get the logs on the same side and compress them. Put the logs on the same side. Awesome. I love these instincts. Okay. And I think it's so important on several levels to actually say these things out loud. On one level, if you know what to do, then it's really good that you can explain your thinking, right? And sort of justify for yourself why you're doing what you're doing. On the other hand, if you're sitting here reading other people's chats being like, how do they just know how to do that? Like, I think it's important to hear why they would do that or what other first steps might be out there. So whether your first step, like your guess, matches with what we do or whether it doesn't, I think either way is a learning experience. Okay. So I don't want you to be intimidated and be like, oh, I don't know. Or like, oh man, somebody said to do that and she said that was good. And that was totally not where I was going. Like, it's not meant to be a shaming experience. It's more like, let's kind of see, right? Let's figure this out. Let's talk about problem solving strategies together. Um, okay. So now that we've got this, if we're going to condense it, it would be wise of us to use not the product property, but the quotient property, right? We want to be really careful, attentive to detail here, that this minus means we change it into a division, right? The other thing we probably want to be really careful about, the base here, they didn't write one. I'm going to write one in for myself, and now it looks exactly like problem number 15. Same structure, okay? So if I rewrite this in exponential form, I'm going to get 5x plus 1 over 2x minus 3 equals 10 squared. Or we could say that's 100, right? And maybe a good way to go about solving this would be to multiply that 2x minus 3 on both sides, right? Get rid of fractions when we can. Right, and I'll give you a moment to just kind of finish solving for x there. Right, and we should get 301 over 195, which doesn't seem like it's going to be a very friendly decimal, so I'm just going to leave it in exact form, okay? But it's a big enough number that I think we can tell when we plug in to here or here, that is going to be just fine. It's not going to create that log of a negative situation, okay? All right. How we doing out there? Any questions so far? Good, good. Okay. So here's what I'd like us to do, okay? Um, we're going to take a look at this last question here, all right? And I'm going to ask you guys to sort of help talk me through it, all right? So we've kind of like both shared that, like I'll help you a little bit here, you tell me some ideas, but I want us to take a look at 17 and start to think about strategies. Like, what might we want to do first? What might we want to do second? Okay. And as you sort of come up with a first step, just type it into the chat or say it out loud, and then we'll kind of work through that and see what we get. Okay. All right, all right. So I see this idea from two folks out there. It's like, let's move everything to one side and then set it equal to 0. Okay. Anybody else have either an alternate first step, or I'd like to hear maybe a variety of ideas if possible. Okay. So we've kind of got two different thoughts, right? One is that let's move everything to one side and just do that all together. And then the other idea here is like combine the logs on the left, on the right. Yeah, on the right. So then we'll be able to get rid of those. Okay. Okay. So in thinking about this, I think in order to answer which one might be slightly better, though I think they're both super great ideas, is to try and practice thinking more than one step ahead. So if I move everything to one side, okay, let's say I get log of 2 over x, then that would be times 3x minus 5, and then I'm going to be dividing that by x minus 1, and all of that's going to equal 0. Okay, so that's one way that I could approach it. If I wanted to clean this up a little bit, I think it's important to think about numerators and denominators. I actually have like 3x minus 5 over x times x minus 1 equals 0. Okay. I don't think that's a bad first step. I don't. I think that one really nice thing about this is my base is 10, but when I rewrite this in exponential form, I'm going to get 2 times 3x minus 5, whoops, over x times x minus 1 equals 10 to the 0, which is equal to 1. So I think that's actually not a bad way to start, okay? I'm gonna let you kind of, if that's the method that you chose, then you could kind of work through it that way, okay? But if we go with the second method that was presented, like let's kind of combine just the things on the right-hand side first, we would get log of x minus 1 equals log of 2 times 3x minus 5 over x, okay? Now I think a nice thing about this one is this goes way back to the bases are the same. I could get rid of the logs and we can go straight to an equation that looks like x minus 1 equals 2 times 3x minus 5 over x. Now these two are going to give us the same answer, okay? So in this case, I'm really glad that we were able to see more than one way of approaching the same problem. I think in this case, both methods are equally easy. I think they have their benefits. I think the benefit of the one on the right, the one on the left is 10 to the 0 is 1. So it's actually not too bad to find out that number. I think the benefit to the other side is you can get rid of those logs and then you don't need to worry about logs anymore, right? So it really kind of depends like which one you think is a little bit easier. I think we'll encounter some problems where one is way easier than the other way. And so then it'll be a good chance to practice thinking ahead, okay? But what I'd like for you folks to do for your classwork for today is you're gonna pick one of these, all right? Or if you have a different method that we didn't talk about, you could try that one as well, okay? But here are two different potential ways of solving this. I want you to pick one of them, all right? I want you to write it out on a separate piece of paper, and then I'm gonna open up a link on Canvas so you can submit your classwork for today, okay? So your classwork is just gonna be equation 17. It's going to be picking one of these two methods that we've kind of already set up and just finish solving them so that you have at least your solution for x. Okay? Does that make sense for the classwork for today? Yep. Okay. All right. So pick a method, try it out. Is it okay if I stop sharing my screen right now, or is anybody still writing down what's on the screen? Anybody need a moment? Great question, Ashley. So let's say that it's 12:30 right now. Let's say that it is going to be due by 1 o'clock, okay? So we'll do it kind of like an exit ticket style. And I'm gonna open up the link. So if you're already done and you can't find it on Canvas, it's because I haven't created it yet, okay? So I'm gonna do that right now, but I'm gonna stop sharing my screen.